Hello class, this is ECON 353 Macroeconomics class. I'm your instructor, Dr. Su. This is for the Tuesday, January 11th, 2021 pre-recorded class video. We continue our discussion about the chapter 1. So after completion of this lesson of chapter 1, you will be able to first evaluate the role that individual self-interest plays in economic analysis. Second, explain why the study of economics is a science. 3, distinguish between positive and normative economics. 4, identify the 3 basic economic questions. Today we are going to watch 5 class video clips, which include 1, the difference between macroeconomics and microeconomics. 2, plotting a linear relationship between 2 variables. 3, changing the intercept of a linear function. 4, overview of economic systems. 5, case study of the work of Adam Smith. So let's watch these video clips.
I know what you're thinking. You're wondering what the difference is between micro and macro, and you want to know which one's easier. Well, let's start with this explanation. Microeconomics is about the decision-making process of individuals. Households deciding whether they're going to buy apples or oranges. A firm deciding whether it's going to install a computer or hire another worker. Macroeconomics is about the aggregate. Whenever you lump together all of these households and business and the government and foreign trade, what kind of organism do you get? In fact, that's a good way of thinking about it. Let's use a biological metaphor. Microeconomics is like the study of a cell, the mitochondria and the nucleus and the way energy is created and the way the cell works. And we put the microscope in on this particular cell and we look at its chemical processes. Macroeconomics is stepping back and letting these cells merge until they become a body, something that doesn't look like a cell at all, but in fact has arms and legs and does different things. Cells metabolize energy. Bodies reach over and pick up an apple and eat it. Macroeconomics is about the study of the economy as an organism. It's an organism that has its own vital signs, like inflation and unemployment and the interest rate and the money supply. Macroeconomics is a look at the overall economy as an organism. Microeconomics is looking at how the cell works. So, apart from this metaphor, how does this work in economics? Well, in microeconomics, we're going to be answering questions about the way individuals respond to changes in relative prices. For instance, in microeconomics, we ask the question, if the wage rate goes up, will a household supply more labor or less? You can argue it either way, right? A higher wage causes you to substitute your energy away from leisure towards labor so that you can afford to buy more toys. On the other hand, the higher wage increases your wealth, which inclines you then to want to take more vacations and to work less. Microeconomics is a study about the way a particular household would respond to a change in its incentives created by movement in the wage. Macroeconomics, on the other hand, steps back and looks at all of these households together and asks a question like, what happens when productivity increases in our economy? will the overall employment rate, that is the percentage of people who are actually able to working in jobs, will that increase or decrease? Do computers increase employment in the economy, or do they reduce it? Macroeconomics asks questions about the money supply. Now, I know I told you before, probably, that economics isn't about money. Well, that's only partly true, because once you're talking about economics as the study of the economy as an organism, money is the lifeblood of that organism. And whenever the Federal Reserve creates and prints and puts into circulation more money, well, people have more in their bank accounts and they can compete more aggressively for goods and services in the market. And that will probably, in fact, most definitely have an influence on the price level, as well as the ease of getting credit and a loan if you are a business that wants to expand. Macroeconomics does study money, and it looks at how the Federal Reserve's activity in the economy, the creation and circulation of money, influences the price level, which in turn may influence businesses' investment decisions and household purchases. Microeconomics, on the other hand, pretty much ignores money. We treat the world as if it's one big barter system where you trade apples for cups of coffee without having to use bills or change. In microeconomics, we look at relative prices. Everything is expressed as maybe 2 apples equals a cup of coffee without thinking about how things are paid for. Whenever relative prices change, people change their purchasing decisions. They change their spending patterns. But in macroeconomics, money is studied much the way that blood is studied in biology. It carries things through the system. It carries nutrition. When the blood supply increases, that changes the health of the organism. Too much or too little blood within a body can create problems. The same thing is true with money in the economy. So one important difference between macro and microeconomics is that micro is the study of individual decision-making. Macroeconomics is the study of the economy as an organism. Another important distinction is that while microeconomics doesn't really pay much attention to money as a phenomenon, macroeconomics takes money very seriously, and the money supply is an important determinant of the health of the economy. Now, in micro and macroeconomics both, there are actors, that is, people who are making decisions. Let's look at who we're going to be studying in macroeconomics and talk about how our perspective on them differs from the way we thought about them in microeconomics. The important players in the macroeconomy are households, businesses, the government, and the rest of the world, which is linked to a particular economy by foreign trade. In macroeconomics, the spending of households is called consumption. Whenever households spend money, they are said to engage in consumption. The alternative to consumption is savings. And another thing a household can do is it can use its income to pay taxes. Now, in microeconomics, we answered questions like, what happens when this household goes to the grocery store? Do they buy apples or do they buy oranges? In macroeconomics, on the other hand, we're going to ask about what determines the amount of consumption spending overall that this household will do in a year. And we'll look at variables like income, taxes, and age as influential on the consumption decisions of this household. What about businesses? In microeconomics, we answered questions like, will this business choose to hire an extra worker or an extra machine at this point? That is, in what ratio will this business employ capital and labor? And if the wage rate increases, we found that businesses were inclined to hire less labor because it was more expensive and substitute and hire more capital instead. That's a microeconomic analysis. On the macro side, what we do is we look at the big picture. When interest rates go up or interest rates go down, are businesses inclined to do more investment spending or less? That is, what influences the overall amount of spending that businesses are inclined to do? Rather than looking at individual decisions within the firm, we consider businesses as part of this overall organism, and we ask what determines the amount of spending that they plan to do. Next, we look at the government. From the point of view of microeconomics, we didn't talk that much about the government because the government seems to mainly be a policy player. In microeconomics, the government set the tax rates, which influence people's purchasing decisions. In macroeconomics, on the other hand, we usually think about government spending as a stimulus to the economy, or government debt as creating bonds, which create a financial market, which has other benefits for the economy. Government plays a big role in macroeconomics as a policy player, not in the sense of influencing individual decisions as they did by setting tax rates in micro, but because the government can choose to pump up the economy by spending more money or to slow it down by spending less. Also, the Federal Reserve, although not technically part of the federal government, really seems like a government entity. That is, the central bank is kind of part of the government, and it's the central bank that determines the amount of money that's in circulation, which influences the price level and other factors, variables in the economy. Finally, we have foreigners, and we didn't talk about foreigners in microeconomics at all. But now the foreign sector becomes very important because the demand for our goods overseas determines the amount that we can export, and that's going to determine how much factories are going to be inclined to produce. Factories tend not to produce goods they can't sell, and foreign demand becomes an important component in the macroeconomy. So, these are the players in the macroeconomy. These are the players, and the way that we think about them in macroeconomics is broadly. Consumers spend money, pay taxes, and save. Businesses spend on investment goods. The government increases spending, maybe runs a deficit, maybe pays off its debt. And foreigners, depending on the exchange rate, may buy more of our goods or less. Now, there's one more thing that we're going to want to consider whenever we think about macroeconomics. I've already mentioned the importance of money in macroeconomics, and that raises the question of being careful whenever we're discussing a particular economic story, of being clear about whether we're talking about a real variable or a nominal variable. Anything measured in terms of money is considered nominal. So for instance, if I hold up this cup of coffee and you can see the price tag on it, if I want to talk in real terms, it's 1 cup of coffee. When we talk about real goods and services, we're talking about physical, tangible, actual goods and services that people enjoy. Cups of coffee, apples, haircuts, vacations, medical care. However, this is also $1.25 worth of coffee. That is, I can represent this coffee in nominal terms by talking about how much money I would have to pay to get it in the market. Things measured in terms of money are called nominal variables. So here is $1, a nominal measure. And here is $1.25 worth of coffee, another nominal measure. The neat thing about nominal measures is they're very easy to add up. If an apple is 50 cents and a cup of coffee is $1.25, 50 cents and $1.25 is $1.75, that's nominal spending. That's how much money I paid out today to get the things I enjoyed for breakfast. However, real goods and services are actual things that are harder to add up because they're in some respects non-conformable. I mean, how do you add apples and oranges and coffee and medical care? What we tend to do in economics is we add up the dollar amounts that are paid for these goods and services, and we divide by something that reduces them to a common denominator. I'm going to be discussing that later, but right now I want you to be clear on the distinction between real and nominal variables. Things that are measured in terms of money are nominal. Things that are discussed measured in terms of physical goods and services are real. Now we'll look at another relationship between two variables represented graphically. In this case, we'll look at the behavior of a hamburger customer, Bob, and we'll look at what Bob does when the price of hamburgers changes. I'm going to now look at a data set that represents the price of hamburgers and the quantity of hamburgers that Bob consumes every week. Let's look at the relationship between these two variables. When the price of hamburgers is $5, Bob doesn't buy any. They are too expensive. Even if the price drops down to $4.50 per hamburger, Bob still doesn't buy any hamburgers. If the price drops down to $4 per hamburger, Bob decides to treat himself to 1 hamburger a week. If the price falls to $3.50, Bob buys 2 hamburgers each week, and so forth. Every time the price of hamburgers drops by 50 cents, Bob decides to buy 1 more hamburger per week. And finally, if hamburgers drop down to a price of $1 apiece, Bob buys 1 every day. That is 7 hamburgers per week. Let's now represent this relationship between two variables, price and quantity, in a graph. First thing that I'll do is I will draw two axes and calibrate them. Here are my axes for this particular problem. The two variables that I'm interested in analyzing are the price of hamburgers and the quantity of hamburgers consumed per week. So let me go ahead then and calibrate my axes. On the horizontal axis, I'm going to represent the quantity of hamburgers consumed by Bob every week. So as I increase my distance from the origin, that is the place where the axes intersect, as I increase my distance from the origin horizontally, Bob is buying more and more hamburgers every week. And those numbers are represented here, 1, 2, 3, 4, and so forth. On the vertical axis, I'll represent the price that hamburgers sell for. The sale price of hamburgers is represented on the axis here, increasing $1, $2, $3, $4, and so forth per hamburger. So on the vertical axis, we have price per hamburger. On the horizontal axis, we have hamburgers consumed per week. If you look in the box, you'll see the information that we were just looking at about Bob's behavior. In the box, you see the number of hamburgers that Bob buys at different prices. I'm going to now transfer that information that's in the tables into a picture here, a representation of the relationship between price and quantity. Let's start then with a price of $5, Bob buys no hamburgers. At a price of $4.50, Bob also buys no hamburgers. So we have points here that are actually on the axis. That is, 0 hamburgers are purchased. So Bob is behaving in a way that gives us points that are on the axis. So here's a price of $4.50 per hamburger and no hamburgers consumed in a week. Now, when the price drops down to $4 per hamburger, Bob actually buys a hamburger. Now we have a point in our space that's right here, 1 hamburger at a price of $4. So that gives us a dot right here to represent Bob's behavior. The coordinates of this point are 1 and $4. If the price drops down to $3.50, so we'll be looking at a price that's right here on the vertical axis, Bob buys 2 hamburgers per week. So now we have a point that looks like this. At a price of $3, Bob buys 3 hamburgers per week. So now we have a point that looks like this. At a price of $2.50, Bob buys 4 hamburgers. So that lets us drop down to another point like this, $2.50, 4 hamburgers. In each case, I'm finding a pair of numbers like $2 and 5 hamburgers, and I'm putting a dot at the horizontal vertical coordinates. 6 hamburgers at $1.50, so find the $1.50 point, and 6 hamburgers, put a dot there. And finally, we get 7 hamburgers when the price drops down to $1. And that gives us a point like this. So these dots represent Bob's behavior. That is, the quantity of hamburgers that he consumes as the price of hamburgers changes. Now we can connect the dots in this diagram and form the demand curve for Bob. That is, we can draw a line that represents the relationship between the price of hamburgers and the number of burgers that Bob consumes in a week. Let me go ahead and do that. I'll draw a line here that connects all of these dots. And it looks like this. And this is Bob's demand curve. We can even put a label on it, say label it with the letter D, to let us know that this is Bob's demand for hamburgers, the relationship between the price of burgers and the quantity that's consumed. Now, if I want to, I can write down the formula for this demand curve. And I'm going to go ahead and do that. Now, I knew the formula before we started because I used the formula to form the tables. The formula for Bob's demand curve is this. The price, that is, the vertical axis variable, is equal to $4.50, which is the price at which Bob will buy no hamburgers, minus 50 cents times the quantity of hamburgers that Bob buys. That is, for every additional hamburger that we want Bob to buy in a week, we have to lower the price of a hamburger by 50 cents. This is the relationship between quantity and price for Bob, and that is the formula for this line. Now, if that takes you by surprise, remember from your algebra class that if we have a variable that's measured on the y-axis and another one that's measured on the x-axis, that the formula for any straight line is equal to this. The y-axis variable is equal to a plus b times x, where y is the variable that we're measuring here, in this case, price. X is the variable that we're measuring here, in this case, quantity. A is the intercept, or the height here on the vertical axis when the x variable has a value of 0. In this case, Bob is buying 0 hamburgers when the price is $4.50 per hamburger. A represents the intercept, and in our case, the intercept is $4.50. B represents the slope of the line, the rise over the run, and in this case, the slope is negative 50 cents. For each additional hamburger that we want Bob to buy, we have to lower the price by 50 cents. So B, in this case, is negative 50 cents. Let's take a moment and remind ourselves about the slope of a line. The slope of a line is equal to the rise over the run. And the rise over the run is the same thing as saying the change in the y variable, that is the rise, the upward movement in the graph, delta y, which in economics stands for the change in y, divided by the run, which is the horizontal movement, or the change in x. So if we want to know the slope of a line, we look at the change in the horizontal, or the change in the vertical variable, divided by the change in the horizontal variable, the rise over the run. Let's look at an example here. If we increase the price of hamburgers by 50 cents, say from $2 up to $2.50, Bob's behavior changes in the following way. Instead of buying 5 hamburgers now, he reduces his hamburger consumption to 4. This tells us the slope of the line, the rise over the run. The rise in this case is the change in the y variable, which in this case is an increase in the price of the hamburger by 50 cents. And the run is the change in the x variable. How does Bob's behavior change? And in this case, he reduces his hamburger consumption from 5 to 4. That is a change of negative 1. So if we wanted to calculate the slope of this line, we would divide the rise by the run. That is, in this particular case, the slope is going to be equal to 50 cents divided by negative 1 hamburgers, or negative 50 cents. Negative 50 cents is the slope of the line, and that's what you see right here in the formula. So for a straight line, the important terms are the vertical intercept, which shows up right here as this constant term, and the slope of the line, the rise over the run, which shows up as the coefficient on this variable. In this particular case, it's the coefficient on the quantity of hamburgers, negative 50 cents. Every straight line can be characterized by these two pieces of information, the intercept and the slope. Let's look at what happens to the relationship between price and quantity when we change Bob's income. We've seen already that Bob has a relationship between the price of hamburgers and the quantity that he consumes per week. We looked at these tables last time, and we imagined, although I didn't say so, that Bob's income was $500 per week. Now, if Bob gets a bigger income, he's going to change his behavior. Let's suppose that Bob's income goes up to $600 a week. If it does, we might expect that Bob would spend more money on hamburgers than before. Let me replace the old set of numbers with the new set. This is Bob's behavior when the income that he earns goes up to $600 per week. In this case, we see that although he still buys no hamburgers at a price of $5 apiece, he'll now buy one when the price drops to $4.50. And then each time the price drops by 50 cents, he'll add one more hamburger to his weekly consumption, so that by the time we get down to $1 per hamburger, Bob's buying 8 hamburgers a week. That is, some days he's eating more than one. Let's now represent this new set of data in the graph that we originally drew. I'll go now back to my two-dimensional diagram with the quantity of hamburgers on the horizontal axis and the price at which hamburgers are selling on the vertical axis. Let's look at this new relationship between price and quantity, the numbers that are now in the table beside me. Let me take my pen and chart these numbers. We can see that now at a price of $5, Bob buys no hamburgers. So the intercept of our term, that is the lowest price at which Bob buys 0 hamburgers, has moved up. The intercept has moved up to $5. At a price of $4.50, Bob now actually buys a hamburger. So we have a point like this, $4.50 and 1 hamburger. At a price of $4, Bob is now buying 2 hamburgers. So we have a point like this, a combination of the price of $400 and the quantity of 2. At a price of $3.50, Bob is now buying 3 hamburgers. So I have the price $3.50, $3, the price of $3.50 and the quantity of 3 represented by this point, and so forth. Every time the price drops by 50 cents, Bob buys 1 more hamburger that he bought before. As we keep moving down to lower prices, we get larger quantities. We still have the same negative relationship between price and quantity. That is, we have the negative slope, the same negative relationship, but the numbers are now different. Here, down at a price of $1, Bob is buying 8 hamburgers per week. I can connect the dots now and form Bob's new demand curve. And let me do that with this new information. I'm going to use my straight edge here to try to draw things carefully. There's no point in being imprecise if I have all the information that I need to be precise. And here's Bob's new demand curve. The new demand curve, which I might label D prime, and the prime, or the apostrophe, just means a new relationship to compare to the old relationship. The new relationship between price and quantity has the same slope as the old curve. That is, notice the curves are parallel. For every 50-cent increase in the price, Bob still reduces the quantity of hamburgers that he buys by 1. So the rise over the run is still negative 50 cents. We've got the same slope. And sometimes we'll represent that by putting 2 marks on these curves, and the 2 marks mean that they have the same slope. They are parallel. The formula for this new curve is going to be given as follows. The price on the new curve is equal to the intercept, which is $5, minus the slope of 50 cents times the quantity of hamburgers times the quantity of hamburgers that's consumed. The formula for the new line is going to be price is equal to $5, that's our intercept, minus 50 cents, the slope, times the quantity of hamburgers consumed. This is the relationship if Bob's income increases to $600. We might think of this as the curve shifting outwards. If we wanted to represent our original demand curve like this, then with the increase in income, we get a new set of points that moves the demand curve outwards. You can think of this as a shift in the curve. Let's look at another set of numbers. Now suppose that Bob's income drops from $600 a week back to a lower income of $400 a week. In that case, what's going to happen to Bob's consumption? Well, here's a table of numbers that represents the number of burgers that Bob consumes if his income is $400. And let's look at these numbers together. What we see is that at an income of $400, Bob is not going to buy a hamburger until the price drops to $3.50. That's the price at which he is first willing to purchase burgers. Then, as the price falls by 50 cents, he'll buy another one, and so forth and so forth. And when the price gets down to $1 a week, and when the price gets down to $1 per hamburger, Bob will buy 6 hamburgers per week. So in this case, we can see that at a lower income, Bob will buy fewer hamburgers at every price. let's represent this set of numbers, which I'll move over to the box, on the graph. Going back to our diagram, with the price on the vertical axis and the quantity on the horizontal, if the number of burgers that Bob buys a week falls because of the decline in his income, we get a new set of points. Notice now that Bob will not buy any hamburgers when the price is $4 a week. So we can put a dot here at $4.00 to represent Bob's behavior with the lower income. This is going to be the new intercept, the lowest price at which Bob buys no hamburgers. If the price drops down to $3.50, Bob will buy his first hamburger. So we get a dot like this. If the price drops down to $3 a hamburger, Bob will buy 2 hamburgers. We get a dot like this. And so forth. Just go through and fill in the numbers from the chart. $2.50 gets us 3 hamburgers. A price of $2 gets us 4 hamburgers. A price of $1.50 gets us 5 hamburgers. A price of $1 gets us 6 hamburgers per week, and so forth. Now, if I want to connect these numbers, I can form the new demand curve for Bob at the lower income. So let me connect these dots. And when I do, I get a new demand curve. And this one we could represent by d double prime. Again, the primes, just to remind us, we have a new relationship or a new set of points. And again, it's going to have the same slope. All 3 of these lines are parallel. One of them represents Bob's behavior when income is high. One represents Bob's behavior when income is in the middle, $500. And finally, the third represents Bob's behavior when income is low. The slope in all 3 cases, that is the rise over the run, is going to be the same, but the intercept is different. And that's what gives us these parallel shifts. This third relationship can be summarized by the equation: the price is equal to $4, that is the vertical intercept, minus the slope of 50 cents, times the quantity of hamburgers that Bob consumes each week. In this case, we have a lower intercept. The curve is closer to the origin, but it has the same slope as before. So, notice the difference between the 3 curves is their intercepts. The first curve is the one that's in the middle with an intercept of 450. The second curve is this one right here with a higher intercept. And the third curve is the one with the lower intercept. Each of these 3 is a relationship between price and quantity for Bob. The difference is in the income. And when the income changes, we get a whole new relationship between price and quantity.
Every economic system must answer 3 questions. The first question is, what will be produced? That is, what combination of goods and services is our economy going to make with its limited resources? What combination of cars and houses, medical care, and vacations are we going to produce? The second question is, how will these goods be produced? What production methods will be used? What way will labor and capital and resources be combined to produce the goods and services that satisfy our wants and needs? And the third question is, who gets the goods? That is, how is the output divided among the people in the economy, each of whom probably wants more? These are 3 questions that every economic system must answer. Well, let's consider the way that one extreme kind of economic system might answer these questions. My extreme example is going to be a system of pure laissez-faire. Laissez-faire is a French word that means let's do or leave it alone. In a laissez-faire system, individuals are allowed to make decisions completely for themselves. I decide how I want to use my time and energy and talent. Maybe I want to be a carpenter and go and hammer nails for money. Maybe I want to build houses and charge people for my services. Or perhaps I sit and think about what I'm good at and decide that I should be a teacher, and I go and I deliver lectures and write books and earn my money that way. In a laissez-faire system, every man and woman in the economy makes his or her own choices about how to use their talents. And typically in a laissez-faire system, prices that arise in market interactions become the guide to people about what they should do. I see that teachers earn a lot of money and carpenters earn less. I'm a relatively good teacher. I'm not so great a carpenter, so I divert my energy into teaching. I train myself to become a better teacher. I'm responding to the incentives in the market prices. This is a laissez-faire system. It's a system in which people are directed, coordinated, and motivated by impersonal prices in the market. And these prices coordinate action among millions of people until they begin to hum along like a beehive, everyone specialized, doing his or her own thing. And the outcome is the wealth that is created. When some people make cars, other people are teachers, other people build houses, and other people raise vegetables. That's an extreme laissez-faire system. And what you get is the law of the jungle. Now, the good thing about laissez-faire is it allows for maximum individual freedom. Another good thing about laissez-faire is that everyone in the economy can respond to information as he or she sees it. Information is distributed throughout the economy. You know things that I don't know. You see opportunities that I can't see. You can discern your own talents probably a lot better than I can. And whenever you respond to the information that only you have, you're going to create wealth that I couldn't create if I were trying to tell you what to do. So laissez-faire allows for freedom and the good use of all available information. On the other hand, laissez-faire often creates messes whenever individuals are doing their own thing and pursuing their own advantage opportunistically. Consider one case. When you're at a football game, everybody's sitting there enjoying the game, sitting in their seats, watching the fun out on the field, and sure enough, inevitably, some bozo stands up. Now, when this bozo stands up, the person behind him or her also has to stand up just to see around. And before too long, everybody, just to be able to see it all, is on their feet. Now, no one can see any better than they could see originally, and everyone's legs are getting tired, and you're more likely to have beer spilled on you. This is a problem, and it's a problem that's a breakdown of the system because people are acting selfishly. This is what happens when we have pollution and litter. It's what happens when people decide not to get a flu shot. It's what happens when individuals impose costs on other people or make choices that don't consider others because there are no prices or other signals in the system to guide them. After all, if I had to pay every time I threw down trash, then that price would connect me to other people. But because I can do it thoughtlessly, we wind up with a lot more litter than we would otherwise get. Also, sometimes in laissez-faire systems, someone will amass a large amount of power because they own a lot of stuff, and they can start telling people what to do. You wind up with monopolies and concentrations of power that we'd like to break up and restore competition and other incentives to create wealth as opposed to hoard it and turn it into power that's actually inefficient. So there are all kinds of things that can go wrong with this view of the world in laissez-faire. So that inclines us to consider another extreme, and that is planned economy. Let's have a wise central planner who looks over all of the resources that we have and considers everything that people want and puts together some master plan that's the creation of a beautiful garden. You go and plant these flowers, you go and be a carpenter, you go and be a teacher, and we'll all trade and have a lot of wealth. Well, this view of the world is great because we'd like to believe that there is someone who has our best interests at heart, who sees the world clearly enough, who sees from 30,000 feet and can direct us in the creation of something better than whenever we're all doing our own thing. The problem with this view, however, is where does this central planner actually get the information that he or she needs to craft this perfect view of the world? How does he or she know what people really want and who's good at what? Not only that, but how does he or she actually get each individual to play their part in the system? How does the central planner get you to be a teacher and you to be a carpenter? What incentives and motivations are offered? Or does this become coercive? See, central planning seems to deny the possibility of a great amount of individual freedom. Either that, or the central planner starts giving out monetary incentives that look a lot like what we got over in the laissez-faire market. So why not go back there? The central planner doesn't get as much information as the individuals have over here in the jungle view of the world. The central planner, if the central planner could get that information, could craft a perfect view of the world. But even then, you got the problem of motivating people to play their part in this picture. Now, all that aside, you still got the problem that once somebody's got enough power to tell people what to do, how do we keep them from abusing that? Aren't people inclined to behave selfishly and opportunistically once they've got their finger on the switch? The problem with central planning is that people at the top can't always be trusted to act in the best interest of everyone in the economy. And people in the economy are all going to be diverting their energies into influencing the central planner to do things their way, which creates a great deal of lobbying and waste. So here we have two extreme views of the world: laissez-faire, which can break down and turn into a mess, and central planning, which can turn into an abuse. So, which outcome is better? Well, your answer to that question is probably going to depend on your politics and your philosophy. But in the real world, what we see is that there are all kinds of mixed systems. Every economy has some degree of laissez-faire and some degree of planning. In the United States, for instance, which prides itself on being a freewheeling, democratic, dog-eat-dog sort of free market, we have all kinds of little islands of central planning. They're called corporations. I mean, what's the difference between a centrally planned corporation and what the Soviet Union aspired to in the 1970s? You've got a group of people here, responsible to shareholders, that are making decisions about what this manager will do and what this division's responsibilities are and who's going to turn out what products on what timetable. So these corporations exist, but they exist within a sea of freewheeling competition and laissez-faire. So there's a mixed system, a system in which individuals can be entrepreneurs and start businesses, but in which there are many organizations which are centrally planned that are part of the landscape. On the other hand, you look at the situation in China, for instance, in which the government maintains a lot of authority over the way the economy works. And yet what the government is choosing right now to do is to allow more laissez-faire in order to increase incentives for more productivity and wealth creation. So here's another mixed system, one where the government isn't afraid to direct traffic. In fact, it's not even afraid to drive some of the bigger cars. But it also allows individuals to be competitive, to make decisions according to their assessment of their gifts and talents and market opportunities. Every economy involves some mixture of these two extremes, laissez-faire and central planning. The role of the government, then, in any economic system is to regulate the mix of these two. In some countries, the government decides to deregulate and stay out of commercial decision-making. At the same time, however, trying to prevent everyone from standing up at the football game, trying to prevent the accumulation of monopoly power, trying to keep people from polluting and encourage people to get flu shots. Other governments decide to take a more active role in the actual allocation of resources. They direct bank lending. They allow licenses for certain people to enter certain kinds of work. You get more government involvement in these cases. But every country and every economic system can be placed on a spectrum, somewhere between the jungle and the garden, somewhere between the freewheeling, freedom-loving, free market, laissez-faire view of the world, and between the view of the world in which some wise planner oversees and directs people so as to create the best possible outcome. The truth is that whenever you're trying to use information well in a system, and whenever you're trying to allocate resources to provide the most satisfaction, that every situation is different, and every situation calls for some different mix between planning and free market. This is Adam Smith, the father of modern economics. Smith was born in 1723 in Kilcaldy, Scotland, and apart from being abducted by gypsies at the age of 3, led a relatively unremarkable childhood. He went to college at Oxford University, where he studied moral philosophy, and at the age of 28 was appointed as a professor of logic at Glasgow University. A year later, he became the chair of moral philosophy. Moral philosophy is the study of the right way for people to live together. And the moral philosophers had an argument with that great philosopher Thomas Hobbes, who had written that people were basically inclined to savagery, and unless there was a strong authoritarian government that kept people in line, that life was inclined to be nasty, brutish, and short, as we lived out the law of the jungle. But Adam Smith disagreed with Thomas Hobbes, and the lectures that he gave at Glasgow University were compiled in 1759 into his first important book, The Theory of Moral Sentiments. Smith had a different view of human nature. He believed that we were hardwired to be compassionate and cooperative, that indeed there was a benevolent providence who guided us through the moral sentiments to get along with one another, to be trusting and cooperative, and that this nature was what made us capable of the production of great wealth. In this book, Smith argues that the foundations for civil society are our moral sentiments, our hardwiring towards respect for one another. Now, a few years later, in 1776, after Smith had moved to London, he published what has become his most important work, an inquiry into the nature and causes of the wealth of nations. In this book, Smith extends his view of human nature to become a foundation for a wealthy economy. Smith wrote this book about the time that the British Parliament was passing all kinds of laws to impede trade among countries. It was the aim of England to get more of its own industries exporting. This is a philosophy called Mercantilism that believes that exports are good because they bring in money from abroad, whereas imports are bad. Smith disagreed completely. He said, look, the aim is not to pile up our coffers with foreign money. The aim is to have a good standard of living, and that England should be as mindful of its consumers who could enjoy inexpensive imports and increase their standard of living as it is concerned about its producers making a lot of money. In this book, Smith lays out a view of how the market works. It is his belief that individuals, by pursuing their own self-interest, are led as if by an invisible hand to create an economy that is wealthy and productive. In fact, Smith argues that we more often create wealth by following self-interest, that is, responding to our own assessment of our talents and our opportunities for making money, than when we intentionally try to do something good for the economy. Consider a passage from this important book, a passage that's often quoted to explain the way wealth is created. It is not from the benevolence of the butcher, the brewer, or the baker that we expect our dinner, but from their regard to their own interest. Every individual neither intends to promote the public interest nor knows how much he is promoting it. He intends only his own gain, and he is in this, as in many other cases, led by an invisible hand to promote an end which was no part of his intention. Nor is it always the worse for society that it was no part of it. By pursuing his own interest, he frequently promotes that of the society more effectually than when he really intends to promote it. That is, if you want to create a wealthy country, that is, if you want to have a commonwealth, the best thing, Smith argues, is to assess what it is that you're good at and look in the economy at where it is that you can make a profit. Because as individuals make profit, they're adding profit for society as a whole. Now, remember, Smith wasn't saying that we should all be selfish. Self-interest and selfishness are two subtly different things. Smith believed that we would be pursuing profit and commercial gain in the context of a society in which people had moral sentiments. That is, respect for one another, respect for property rights, respect for the law, respect for telling the truth, and the accurate representation of their goods and services. If people were basically ethical and compassionate and collegial, then the pursuit of self-interest was the most effective way to make the country rich. Smith, on his travels in England, observed an instance in which he saw the benefits of the market economy. Here was a pen factory in England, a place where straight pens for clothes were manufactured. Smith walked into this factory, and what he saw was a remarkable division of labor. He saw that the tasks that went into making a straight pen had been divided so that each person had their own job to do. One person pulled the wire, another sharpened the point on the end of the pen, yet another person put the cap on the pen or the head, another person stacked the pens into the papers in which they were sold. So the production of straight pens involved several tasks, and the division of labor made this easier to do. Imagine, Smith says, if you had to do all these tasks yourself. Not only are there some tasks you're not especially good at, but you'd have to set up for each new job. That is, you'd have to go get one set of tools to stretch the wire, another set for grinding the point on, and so forth. But when there is division of labor, each person has his or her own job. Each person concentrates and specializes in an aspect of the job that he or she is especially good at. Plus, you economize on setup time. Instead of moving from one job to another, you keep doing the same thing over and over. And this created an incredible increase in productivity. One person may be able to produce 10 pens a day, but 4 people could produce 10,000. Now, Smith said, you got to worry about this guy who's stretching wires all day. Isn't he going to become kind of dull and bored? Can you really let such a person play an active role in the government? Smith was concerned about what the production process and specialization and division of labor would do to the human spirit. And that was his advice to managers. Beware that you don't make your workforce dull with excessive specialization. But it's this invisible hand that sticks with us, this belief that by each of us doing our own thing, in the context of an economy where we respect one another and property rights, that we create the wealthiest possible outcome. Now, Smith was concerned about cases like pollution, where people were doing what they thought was good, but at the same time imposing costs on other people. He was concerned about monopolies, where a concentration of economic power could lead to inefficiency. He was concerned about cases where one person knew more about the good being traded than the other person, so that trust could break down and people behaved defensively. He was also concerned about the poor and how the market didn't always provide for them. But in the end, it's hard to tell whether Smith is really coming down on the side of saying that laissez-faire is the way to run the economy, although he definitely believed in a free market, or whether he's saying that these exceptions, these problems that can arise in a laissez-faire economy, justify more involvement from the government. You can read the books either way. Either Smith was a free marketeer, or he was a careful apologist for the role of the government in the economy. Whichever way you look at it, it's hard to forget that individuals pursuing self-interest, creating something of great wealth, that metaphor sticks with you. And it seems that Smith laid down the challenge to all future economists to justify government intervention because, he says, leaving people to their own best lights about how to make money is the surest way to ensure the wealth of a nation.
Economists use graphs to represent a lot of their analysis. So we'll take a while here to review how graphs work and see how we'll be applying them throughout the lessons. You're familiar with graphs like pie charts, which show you how one sum can be divided up into its parts. You're also familiar with bar charts that show you how a sum changes over time or can be divided up also into its parts. In economics, we're going to use graphs in two-dimensional space, and these graphs usually represent relationships between two variables, or in some cases, relationships among 3 variables. What we'll do in this lesson is show you how those graphs work and prepare you for tools that we'll be using in other lessons. Let's start by having a look at the two-dimensional graph space. We have a vertical axis along which we measure the quantity of one variable, and a horizontal axis along which we measure the quantity of another variable. And usually these two variables are related in some way that the economist finds interesting. Let's look at an example of information that we represent in this two-dimensional space. Suppose we want to graph the relationship between two variables, consumption and household income. Consumption is the amount of money that a household spends on goods and services, and income is their income, the money that they take in from work and other sources. Now, how are we going to represent the relationship between consumption and income? Let's start by graphing income on the horizontal axis, and I will use this abbreviation, INC, to stand for the household's income. And we'll measure this income in dollars. So I'll put a dollar sign here to remind me that everything that's measured on this axis is measured in dollars. Now I can calibrate the axis by marking off these tick marks and putting numbers along them so that I have a scale along which to represent my information. Let me let each of these tick marks represent $10,000 worth of annual income. So the first tick mark here I could label 10 for $10,000. The second tick mark I could label 20. The third I could label 30. And I might want to be careful here not to put too many numbers close together or the graph could start to get crowded and unwieldy. So what I'll do is I'll skip every other 10,000 and represent 10, 30, 50, 70,000. Here's 80. I'll skip it. 90, 100,000, 110, and 130. And the numbers, of course, continue as you go out. The numbers increase, representing larger annual incomes as you move to the right. On the vertical axis now, I'll represent the other variable, and this is going to be consumption spending, which I'll represent with the letter C. So as I increase my vertical altitude here, I'm increasing the consumption spending of this household. I'll put a dollar sign here to remind me that consumption is measured in dollars, and I'll do the same thing that I did on the horizontal axis. I'll calibrate using tens, and I'll skip every other one so that I don't get too crowded. Here's $50,000 in annual consumption spending. Here's 70. Here's 90. Here's 110. And just let the numbers go on up. Now, what I do in this space, now that I've created it, is I can represent information about consumption spending. Suppose I have a table of numbers, and one of the numbers that I have, suppose I have a table of numbers, and each one of these numbers represents the income spending information for a particular household. Each household, each data point that I have represents the behavior of a household. So I'm going to put data points in this graph, and each point will represent the behavior of one particular household. So suppose I have a household, and I know that their annual income is $30,000, and their annual consumer spending is $40,000. Now you might ask, how can that happen? If their income is only $30,000, how could they spend $40,000? Well, perhaps they have other sources from which to get money. Perhaps they have savings that they can draw on, or perhaps they receive payments from the government or other sources of income. So if I know that a household that has a $30,000 annual income is spending $40,000 a year on consumption spending, I will go up to this point and put a dot where those two numbers come together. Now notice, the horizontal coordinates of this point represent the income of the household, that is $30,000. The vertical coordinates represent the consumption spending. So see, each point in this space represents a combination of two pieces of information about a single household, their annual income and their consumption spending for that year. I can label this point with a pair of numbers that represent its coordinates. I'll write first the horizontal coordinates, that is 30, to represent their income, or 30,000. And second, I'll write the vertical coordinates of 40 to represent the spending data. Now, sometimes you'll hear the information represented here called the x variable, or this number called the x-axis. The horizontal axis is sometimes referred to as x, and the first number here represents the x coordinate. Sometimes this axis is called the y-axis, and the number that's represented here is the y-coordinate. So the numbers in parentheses are the x and the y, the horizontal and the vertical numbers here, written side by side. And each point in this space will have two numbers, two coordinates associated with it. Now let's suppose that I have data on a lot of households, and I know the income and the spending for several households. I can represent the points in this space and form what we call a scatter diagram. The scatter diagram just tosses the points out in this space and looks at them. So why don't we do that? If I have information, say that a house that has an income of $10,000 was spending $30,000 that year, I can put a point here with a horizontal coordinate of 10 and a vertical coordinate of 30. Suppose I know that a household that had $90,000 annual income was spending 70. So let's put a point up here with a horizontal coordinate of 90 and a vertical coordinate of 70. By the way, what was that household doing? If they were spending less than their income, then they were saving the difference. And then, suppose I have a lot of other points. I'll just graph some samples here. Suppose I had a point like this one, and 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 so forth. Each point represents a combination of income and spending for one particular household. And as I fill in the information that I have, in each case I'm representing the household's income by the horizontal and the household's consumption by the vertical. This is a scatter plot. It's information arrayed in a two-dimensional space to represent two variables for each data point. That is, the income and the associated consumption spending for one particular household. Now, once you've got a scatter plot like this, the next thing that you're tempted to do is to fit a line to that information to notice the general relationship between the two variables. Notice, as we look at this information, in general, as income increases, consumption spending increases for these data points. We say that there is a direct relationship between income and consumption, a direct relationship or a positive relationship between these points. If I wanted to notice the general relationship, I could fit a line to these points that would look something like this. And this line represents the general relationship between consumption and income. That is, in general, for the points in this data set, as income increases, consumption spending increases. The thing that's important to notice here is because of the direct relationship, the line that passes through these points has a positive slope. Now, what does that mean, a positive slope? I'll get to that in just a moment. But I want to stop here and make the point that in economics, one of the first things that we do is we notice general relationships between data points. We notice, for example, that when income increases, consumption increases, we observe a positive or a direct relationship among the points. We've been looking at linear relationships between variables and how economists think about these. So far, everything that we've looked at has had a constant slope. That is, we've been analyzing straight line relationships, such as the relationship between price and quantity in Bob's demand for hamburgers. Now we're going to look at a relationship that is not linear. In fact, it's what we call curvilinear. It is a line that's not straight. We're going to see how we draw a relationship like that and how we calculate the slope of a relationship where the slope is not constant. In order to do that, let's look at the relationship between labor and output for a firm that makes television sets. And I've made up these numbers so that I can fit a curvilinear line to them. Here is my relationship. If you have one worker working by himself, he can make a single television in a day. If you have 2 workers cooperating, they can make 4 televisions in a day. If you have 3 workers, 9, 4 workers, 16, 5 workers can make 25 televisions, and so forth. Now, notice this relationship is one of exponential increase. That is, the number of TVs are increasing much faster than the number of workers. So in this case, our slope will not be constant. Let's represent this relationship now in a picture. I'm going to take my axes here and use the axes to represent the amount of labor that the firm uses. So we're going to measure labor on the horizontal axis. And on the vertical axis, we're going to measure output. And in this case, it's going to be output of television sets. So each point in this space will represent a combination of labor and output. This is a production relationship. So, for example, one worker is able to produce a single television if he's working by himself. So since I've calibrated these axes where each of my lines represents 2 TVs, my first dot will be halfway up towards this point at 1 worker and 1 television set. So here's my first point on my product curve. The second point on my product curve will be 2 workers and 4 television sets. So that's going to be at this point right here. 3 workers are able to produce 9 television sets, so that gives me a point like this. 4 workers are able to produce 16 television sets, so follow this line up here to 16. And 5 workers can produce 25 television sets, so follow this line all the way up to 25, which will be right here. Now, connecting these dots is going to be a little bit more complicated than connecting the dots in our earlier story. In the earlier story, all we had to do was pick any 2 points, draw a straight line between them, and we had a demand curve. But the production curve is not linear. That is, the slope is not constant, so I have to draw a curve that connects these points together. That curve is going to look something like this. Let me take a curve here and figure out how to make it fit. I want it to go through this point, and this point, and this point, and this point, and this point. And so my curve is going to look something like this. It's going to be an exponential relationship. So if I want to connect my dots, I'm going to have them lying along a blue line that looks like this. Let me go ahead and draw that blue line in. I could have kept that curve there and just drawn along it, but I'm going to try, and it takes practice to do this well, to connect my blue dots along a single curved line. It's like this. Well, that's not bad. So I'll go ahead and make this line a little bit darker. And there's my production function for a firm that hires workers to produce television sets. And we might call this curve the total product curve. We'll be studying this later in the lectures. So I'll go ahead and label this TP, total product. And this total product curve depends on lots of things, like the technology of the firm and the size of their factory and other things. What I'm mainly interested in at this point, though, is figuring out what the slope of this curve is at a particular point. Say, for instance, we are looking at this point right here, the point where we're hiring 2 workers and making 4 television sets in a day. And I'd like to know, what is the slope of the curve at this point when I'm hiring 2 workers and making 4 television sets a day? What's the slope of the curve? That is, what's the rise over the run? How many extra television sets will I be able to produce if I hire an extra worker? Well, to calculate the slope of a straight line, it's not quite as simple as looking at 2 points on the curve. Because as you move from one point to another, what's happening is that the line itself is changing its slope. Down here, our blue curve is relatively flat. That is, if we look at a point down here, we get a relatively flat line. But as we move up the curve, notice, the line is getting steeper and steeper and steeper. The slope is changing all along this blue curve. So if we want to calculate the slope at a particular point, we can't just look at the slope between 2 points on the curve, because as you move from here to here, even that small movement represents a change in the slope, or causes a change in the slope of my total product curve. The blue curve slope is changing. Well, here's how we do this. We calculate the slope of a single point on this curve. We calculate the slope at a single point by taking the limit of slopes of lines that connect 2 points on the curve. So for instance, suppose we look at what happens as we move from 2 workers to 4 workers. As we move from 2 workers to 4 workers, what happens is this. We're moving along a line that connects those 2 points, and the line that connects those 2 points is this line right here. This red line connects those 2 points. Now, what's the slope of that red line that connects this dot with this dot? What's the slope of that line? Well, let's calculate it. The slope of my red line here is equal to the rise over the run, or the change in the vertical axis variable, that is a change in the number of television sets, divided by the change in the number of workers. Well, the change in the number of television sets is going to be 16 minus 4, which is going to be equal to 12, and divide that by the change in the number of workers, which is going to be 4 minus 2, and that's going to give me a slope of 12 over 2 equals 6. The slope of this red line right here, that is its rise over its run, is going to be 6. The slope of that line is 6. However, if I took a different red line, say the red line that connects this dot to this one, its nearest neighbor, we're going to get a different slope. Let me go ahead and draw that. If I connect this dot with the nearest neighbor, my red line is going to be a bit flatter. Now, it's a little harder to see that line because it's almost right on top of the blue line. But what we've got here is a line that connects this dot with its nearest neighbor. I'd like to know what's its slope, what's the rise over the run as I move from this point to the next. So let's look then at the slope as we move from 2 workers to 3 workers. In that case, the slope once again is rise over the run, but the slope along this point is going to be a little bit different. The slope in that case is going to be equal to, the output has changed from 9, or to 9 from 4, divided by a change in workers from 2 to 3, gives a slope of 9 minus 4 is 5 over 1, which is going to be equal to 5. So the slope at this point is 5. Notice what's happening. As we move from this original red line that connected these 2 points to the red line that connects 2 closer points, the slope is getting flatter. It's gone from rise over run of 6 to rise over run of 5. Eventually what happens is if we let the point that we're looking at get closer and closer to our original point, if we let the point that we're looking at get closer and closer to our original point, we're eventually going to come up with a line that has a slope that is equal to the slope of the blue curve itself. Eventually what we get is what we call the tangent line. The tangent line is the line that just touches the blue curve. If you had something straight like this ruler and you wanted to lay it against the blue curve, laying the ruler against the blue curve would give you the tangent line. Laying something straight against a curved line at a particular point gives you the tangent. Tangent means touching. If you wanted to take the blue curve like before and lay it against the blue curve and have this blue curve be a straight line, the slope of this blue curve now is the slope of the tangent line, the line that just touches. So to calculate the slope of a curve at a particular point, you take the limit of the slope of the lines that connect that point to other points And that limit is going to be the tangent line, the slope that's tangent. So when we're looking for the slope of a curved line, we take the slopes of lines that connect points on the curve. Let those slopes change as the point gets closer and closer to the point we're interested in. And finally, we come up with a line that's tangent to the curve at the point we care about. In this particular case, from calculus, I know that the tangent line that I've drawn here with a dash has a slope of 4. I'm not going to do the calculus right now, but what I'm interested in your understanding is that when you have a curved line, the slope of that line changes as you move along it. And the important thing for you to know that the slope of that curve at a particular point is the slope of a straight line that touches the curve at that point.